Hello everyone, this is How I Love Geometry. I'm Mr. Chang. This problem is from 2023 Aime 1, problem number 12. Let triangle ABC be an equilateral triangle with side length 55. Points D, E, F lie on BC, CA, and AB respectively, with BD equals 7, CE equals 30, and AF equals 40. Point P inside the triangle ABC has the property that angle AEP, this angle, equals angle BFP, this angle, equals angle CDP. Let us find tangent square of angle AEP. So we know tangent value, right? We can try like this way. And if this is perpendicular to this one, and also we can find, because these three angles, they are equals to each other. So also we can use this side over this side. Also we can use this side over that. So I labeled this one is X, and this point is Y, and this is Z. So this problem now we can find, we can use this Py over Ye, or Px over Dx, or you can use Pz over Zf, because all of these three angles, they are equals each other. So if we can find this one and over this one over this one, but another way, because the tangent is the same, so it means Px over Dx. It means Px over Dx equals Py over Ey equals Pz over Fz. They are the same. So another way, we just, if we can find each one of them, another way we can find, this is tangent. If we say alpha, that's tangent alpha equals this one. So we can put them together, right? Px plus Py plus Pz over Dx plus Ey plus Fz. And this one on the denominator, right? On the top, denominator. So denominator, it means point P to the three sides distance, sum of them. So it looks like it's a fixed number, right? Yeah, we can prove, we can try this one. Let us say, if this is a equilateral triangle, if this point is here P, any point inside, so it looks like this way, right? We just check if it's correct or not. So if I say this is H1, and this is H2, and this is H3, now it's about the height. We can use the area, right? If the length of this side, each side is A, so the area for, we can use this triangle is 1/2 A times H3, then plus this one, 1/2 A times H2, and plus 1/2 A times H1. So this must be equals 1/2 A times H. So if I say from this is H, okay? If this is H, so it's obviously 1/2 A, 1/2 A, 1/2 A, 1/2 A. So it means H1, H2, H3 equals H. And H equals how much? Equals A times sine 60 degrees. So it's square root of 3 over 2 times A. And for this problem here, we will got which one? So it's square root of 3 over 2 times 55. Okay, now we just wanted to find this one. How to find this dx plus ey plus fz? So to solve this one, if we know the length of this, then we can use this minus 40, it will be zf. And if we know this one, the length of this one, then minus 7 will be dx, right? And if we know how long for this one, I mean cy, and we can minus 30. Of course, we just want to know the sum of them. So if we know az plus bx plus cy, yeah, the problem we're solving, right? So to find this one, now I want to introduce another conclusion for that in a triangle. So if this one is any triangle, there is a point inside. We call P. That's A, that's B, that's C. If I say this triangle, perpendicular, then we will find what I want to say. This side and this side and not side, this segment and this part. So we will find, and if I say D, E, F, so our conclusion is AF squared plus BD squared plus CE squared equals BF squared plus CD squared plus AE squared. Okay? Yeah, we can also use the same way. It's not the same way, but we use the Pythagorean theorem to find this one. So we know AP squared equals AF squared plus FP squared, right? AF squared plus this squared. And this also equals which one? Equals AE squared plus EP squared. Then we do the same thing for this one, for the second one. So we will get BD squared plus DP squared equals BF squared, this triangle, plus FP squared. And next we will see CP, right? And I want to see CE squared. C squared plus EP squared equals which one? This DCD squared plus PD squared. So if we plus all of these three sides, and I mean these three, put them together, and for the right hand side, we will this one and this one cancelled. FP squared, DP squared, and PD squared. So the left hand side is this one, F squared plus BD squared plus C squared, and equals this one. That's right hand side, AE squared and BF squared and CD squared. Okay, so this conclusion no problem. Now we can use this. Go ahead, and we will find another one. Now it's special in the equilateral triangle. If this in the equilateral triangle, if this point P and this is for the distance for this one, for this side, for this side, so A, B, C, D, E, F. Now the conclusion is AF plus BD plus this CE. What do we want to get? AF plus BD plus CE equals 3/2 of the side of this equilateral triangle. Let's say it's A. Side lines, I mean AB and BC and CA, all of them equals A. So let's just prove this one. Because AF plus BF then squared, that's A squared, right? And we got BD plus DC then squared, that's another A squared. And finally we got CE plus AE then squared. So equals 3A squared. No problem for this one, right? And we just extended all of this 3. So AF squared plus BF squared plus 2 AF times BF, right? And next part is this one. BD squared plus DC squared plus 2 times BD times DC, then plus this part. CE squared plus AE squared plus 2 times CE times AE, then all of them equals this, right? And we know AF squared plus BD squared here plus CE squared equals to this one. BF squared plus CD squared plus AE squared equals, they are the same. So I can use 2 times of this, right? And then all of them is 2. So each side I divided by 2. It means I got AF squared plus BD squared plus CE squared. And plus AF times BF plus BD times DC plus CE times AE equals 3/2A squared, right? Each side divided by 2. So, and I will figure out AF. AF, then AF plus which one? BF. And I factor out BD, it will be BD plus DC. And I factor out CE and CE plus AE. So equals 3/2 A squared. And we know this is AF, BF. And also this is A, BD, DC. And also this is A, CE, AE. So each side divided by A. Then I will get AF plus BD plus CE equals 3/2 of the side length times A, right? Also you can say 3A is the parameter and 1 is half parameter. Okay, right? Half parameter. Now this will help us. That's what we want to get. So for this problem, now we want to find the dx, ey, and fz, because we know az, according to this conclusion, z is the perpendicular point. So az plus bx plus cy, there will be this one, right? 1/2 of the parameter. And if I use this one over 2, that's right, minus this 40, that will be fz will be left, right? And if I also minus 7 here, and dx will left. And finally, minus 30 and ey will left. That will be what we want to calculate, right? That's dx plus ey plus fz. So equals 165 minus 2 over, that's 70, 77, 154, right? That's 11 over 2. Now, we know this is 11 over 2. So we can calculate the tangent value for alpha. And 2 and 2, that's 11, that's 5. So is 5 times square root of 3. And the problem let us to find the tangent square of this angle AEP. It will be 5 times square root of 2, then squared. So that's 75, right? We're done. This problem is a little hard. And if we use this way, we need a lot of fundamental knowledge about that. So it's because this problem is so special in the equilateral triangle. So this conclusion is easily to get. And this one, sometimes we can easily to think about. And for this one, yeah, also not easily to know. But after this problem, yeah, we will know all of this. If we have this fundamental knowledge, then the problem will not so hard to solve it. I hope you enjoy it. Thank you. We will meet in the next video. Okay?